Alright, so this is sort of part 1 of 2 for our practicum for week 3 of, week 2, week 3 of computational archaeology. So in this first part, this is going to be a standalone video just showing you how to access the USGS Geospatial data portal that's also known as Earthexplorer. So what you need to do is to load up your favorite web browser and point it to earthexplorer.usgs.gov. And once you get over there, what you need to do is first you need to create an account if you don't have one already. So there should be a register button over here now. I've already logged in, so you don't see it. And you have to go through a few steps, tell them how you're going to use the data. And if you're a student in the class, obviously you're going to do it in an educational context. And it's a free account. You just set it up with username, password, then make sure you log in. And as soon as you've logged in, now you're pretty much ready to go to access and download free geospatial data from the United States government. So this is what you should see when you first open this and log in. It's by default zoomed in into basically the center of the United States. There's a couple of different ways you can navigate. So if you see, once your mouse cursor goes into the map area, it turns into a hand. So you can click and pan by dragging, click and hold and drag it around. The scroll wheel will work to zoom in and zoom out. You can also zoom in and zoom out with these tools over here. You can change how it looks if you really wanted to, sort of the base layer that you're looking at over here. Probably the default is good enough. And so what you're going to want to do is to navigate to the part of the world that you want to see if they have any data for, and then you'll put in some bounding boxes like so. So here I've just randomly clicked around in the sort of, I guess, Midwest, upper Midwest of the United States. You can see each one of these pins is a sort of vertex of vertex of this square polygon, and I can put as many or as few pins as I want. And you'll see they'll show up over here with their latitude, longitude coordinates. If you made a mistake, you just go over here and you can X out of them like so, and you'll see they'll sort of delete them one by one. You can also click the add coordinates and type them in very precisely here, so you can add each pin individually. If you, for example, have a GPS point and you know very precisely that's the corner of the area that you're interested in, you can certainly do that as well. The other thing that you can do is to sort of search. You can do a couple of different things. You can actually click this tab, and you can actually upload a shapefile or a KML file, which is what you would export from Google Earth. And shapefile is a standard vector format. That's sort of the bounding box of the area that you're interested in. And you can upload that, and it will just use that as the bounding box. On the other hand, you can go to the tab that says Geocoder, and you can put in a couple of other sort of identifying features. The most useful one is probably address place. So that's actually what we're going to do here first. We're going to search for the city that is closest to the little project area that we're using in Project 1, which is in Calabria, Italy, and the town that we're going to search for is called Bova Marina. So that is B-O-V-A space M-A-R-I-N-A. So you type it into that box and you hit show, and it should show you the actual address here in the latitude, longitude. So you can click on it and it should zoom right in there, and it should have a pin already in place. So I'm going to use the scroll wheel to zoom way in so I can show you. So there it is. This is the little town of Bova Marina. So this is where I stay in the summer times when I'm out doing field work. And just over here to the east of it is a valley. This is the San Pasquale Valley, and this is the valley that you're going to use for actually quite a few of the projects in this semester. So this by default has now been added as a coordinate, so that's totally cool. We can then go in and click a couple other coordinates, and really all we care about is just getting the main center part of the valley. This is the town of Bova, or Upper Bova, so you might want to put the pin on Bova and make it sort of parallel. And maybe the other pin can be on Palizzi Marina. And between all of these things, maybe we want to extend these so we get the entire coastline. That's pretty good, like so. It doesn't have to be exactly the way I've done it here, because what it's going to do is to show you the overlap of any GIS tiles that they have for download. Any GIS tiles that actually overlap in any way with this area will show up in the search. So once we're happy with our coordinates, and again, we can drag them, we can add additional ones, we can delete the new ones, as soon as we're ready to do it, what we can do is to go down to the very bottom here and click where it says Data Sets. And this is where we get an opportunity to choose what kind of data we want to search for. And as you can see, they have quite a few different varieties of them. So later on in the semester, we'll deal with imagery. Specifically, we'll deal with Landsat imagery. Also, we'll talk a little bit about imagery from commercial satellites and declassified data. So these are like Cold War spy images. So at this moment you can take a moment and sort of click through some of these things just to see what they are. But what we really want to do right now for Project 1 is to download some digital elevation data. And you can see there's several of these. Some of these are just for North America, or in fact specifically just for this one's just for Alaska. But the one that we're particularly interested in is SRTM, which stands for Shuttle Radar Topography Mission. And this is a global data set, and it is actually available free of charge from USGS at a 30-meter spatial resolution, which means every pixel is going to cover a swath 30 by 30 meters, which is actually pretty high resolution for a global data set. So it's a super useful data set. It's actually pretty accurate because it was done by a radar system that is an active sensor. So that literally the space shuttle had two devices. One would pulse the radar signal down, the other would wait for it to bounce off the surface and return. And based on the timing between when it was sent and when it bounced, you can know pretty precisely the average elevation within that 30-meter pixel. So what we want to do is to get the one that is SRTM 1 arcsecond global. And your clue here is arcsecond, so we know that it's going to be in a latitude, longitude system, an angular measurement system. So that's going to be our base initial import, and later on we'll figure out reprojecting it when we get halfway through the course into GRASS. So all we want to do is to put a check mark over here, and once we're cool, you can add additional criteria. So you can actually put if you know some other like specific ID numbers, you can put them there, but typically it's just sort of useful once you check the box just to go straight to results. And in our case, we've just got one that overlaps. And if you want to double check, you have a couple of tools over here. Pretty useful is the footprint tool, and it actually shows the coverage of that individual tile. So obviously, since this is a global data set, you can't get the whole world at once, or you'd be here for days and days and get terabytes of information. So they break them up into these 1 arcsecond tiles, and you can actually get basically like a mosaic. If you wanted to cover all of southern of Calabria, you need to get the one that was up here, the one that was over here, and the one that was over here. And you can download them individually and composite them back together in your GIS, and we'll cover that again later on in class. But for now, this is the only one that we really need is the one that covers our little project area of San Pasquale Valley. So that's the footprint. Over here is a browse overlay, so it actually gives you a sort of scaled back miniature view of what the data actually is. This is pretty useful specifically, or especially if you're getting imagery data and you can actually see what it actually is. And there are a couple other things you can compare. If there's, for example, imagery from one date versus another, you can put them in a list to compare, so you can choose the best one. You can look at the metadata, which is essentially like, the date that it was captured, the date it was published, the corners and, the coordinates of the corners, and a few other little bits of information. Again, depending on what kind of data, you'll get some other information here, so that's also potentially pretty useful to look at. But for us at this particular point, what we want to do is to go to the Download Options tab. So click that button, and you'll see that there are actually 3 different formats that we can download them in. Now, depending on which GIS software you're using, it may be advantageous to pick one of these versus the other. For us, we're going to pick GeoTIFF. GeoTIFF is a pretty standard accepted raster format for most GIS systems, and so that's what we're going to do. QGIS reads these in just fine. So click the download button, and it may say waiting, and then it's going to download it. By default, it's just going to put it into the downloads folder of your computer. You might get a little pop-up that asks you where to download it, so that could be a useful thing. But once this guy is finished downloading, then we're basically ready to go. We can continue to search for different data sets, so we can go back over here, clear our SRTM, and we could continue to search for other different kinds of data sets if we really wanted to. But for us, all we really want is that SRTM, so we're done. We can essentially close out of that. What I will do briefly before ending this first part of the practicum is to show you how you'd want to organize your data set. So I've opened up my download folder, and what we want to do is to find this one, and it has a very strange name, N37_E015_1ARC_V3.TIFF. And what this is saying, the tile is north 37, east 015. It is 1 arc second coverage, and it's the version 3 SRTM. It's the most up-to-date, most recent version of the SRTM data set. So that's how you'll identify it. If you download more than one, it might say, the one just north of this would be north 38, east 15. The one just to the east would be north 37, east 16, right? So, or 14, whichever way the numbers go. So that's how you will sort of, in your mind, organize how you're going to do all this stuff. Now, what we want to do is to open up our QGIS projects folder that we made last time. So here's my one from last time, QGIS projects, ULA. Then we have SPV survey, if you recall, and there we have raster and vector. So we want to go into the raster folder. And here at this case, we just have one orthos.tiff, and we can pull this one directly in here. Now, real best practice would be to make a new folder that says DEM or elevation or something like that, and then to put our SRTM into there. And technically we should have one that says imagery. Oops, let's actually type the entire word imagery, like so. And we can put San Pasquale orthos in here. So you should already be in your mind going, oh, we just moved San Pasquale ortho into a new folder. That might do something to our GIS project when we open it up. So if we go back here, just one folder up, and we open our SPV survey.qgs project file, it's going to open QGS, and then it's going to say handle bad layers, San Pasquale orthos.tiff. It means it can't find it now because I moved it, and it doesn't know where that file is. So what we can do here is we can highlight it, and then we can click Browse. And what we need to do is to go into our project folder, SPV survey, go now into raster, and our new folder imagery, and then say, there it is, San Pasquale ortho.tiff. And then click OK, and now we can find it. And so you'll see I'm right back where we left off last week. My 2017 structures outline is in there. It's styled exactly the way I last left it. And now that we told it where the orthos are, the ortho photo is, it knows where those are and it can display them as well.